And now we want to solve this problem for a circuit that contains a resistor and a capacitor. What are we required to find? We've got this diagram here, and so we have to calculate the reactance of the capacitor, II, the current flowing in the circuit, III, the voltage across the capacitor. Now you see the diagram clearly on the board there. This is an RC circuit. RC AC circuit. An AC circuit that contains a resistor and a capacitor. It therefore means that what is opposing the current here, there are two elements, a resistor and what? A capacitor. So we're talking about impedance along the line here. When we get there, we'll analyze that. Solution. Now from the question, let's bring out the data. We know already the resistor is given to us to be 500 ohms. Alright, that is the resistance in the circuit. And then we're given the capacitance in the circuit C to be 5 microfarad, which is still the same as 5 times 10 raised to the power minus 6 farad. And as a unit, we know the voltage, the AC voltage. Take note, this voltage is instantaneous voltage, please. Because that's the voltage in the alternating current circuit. The voltage that moves in an AC circuit is known as the instantaneous because it changes with time, you know. So whatever current you're going to get from this voltage 10V is also known as instantaneous current because it is expected also to change with time. Okay, so V here, V, it's 10 volts. And then we're given 50 per second. This per second is another unit for hertz, frequency, right? Another unit for frequency, so it's the same as the hertz. Is that okay? So frequency F is equal to 50 per second, or let me put that hertz. Good. The first part of the question, we have to determine the reactance of the capacitor. Reactance of the capacitor is the same as capacitive reactance. And capacitive reactance is 1 over omega C, alright, which is also the same as 1 over 2 pi Fc. Omega is 2 pi F. So we have to write it in terms of frequency because we're given the frequency from the question. So the capacitive reactance will now be 1 over 2 pi times the frequency. From the question, the frequency is 50 times the capacitance of the capacitor, which is 5 times 10 raised to the power minus 6. If you work out this, the capacitance, that is the capacitive reactance of the circuit, the opposition offered to the flow of current by the capacitor is going to be given by this. So have 1 divided by, 1 divided by, you can put all this term in denominator in a bracket, so that's going to be 2 pi times 50 times 5, then times 10 to the power of negative 6. Alright, you would recall that in one of the questions we solved previously, that should be question number 1, I moved this 10 raised to the power minus 6 to the numerator in order to make it positive. So it's still the same thing. This time around, I chose to leave in the denominator. So it's going to carry the minus 6. And from here, this gave me 636.62. 636.62 ohms. So this is the opposition offered to the flow of current by the capacitor in that AC circuit there. Now the second part of the question, we have to determine the current flowing in the circuit, II. Current flowing in this circuit. This current is an alternating current. Is that okay? And when you're dealing with this current flowing in this circuit, it's going to be instantaneous current because that current would have to change with time. So we're going to obtain it from this voltage. But remember, determining current, we need an ohmic form of equation. Ohm's law, I equal to V over R. You use that R if the circuit is simply a resistive circuit. But friends, you didn't take note of this. Alright? This circuit, not the only resistance circuit. It contains resistance and capacitance. So the opposition offered to the flow of current here, which is going to be the denominator when dealing with Ohm's law, V over the denominator, that denominator is no longer going to be resistance, R. It is no longer going to be capacitive reactance, XC. Rather, it is going to be the combined opposition offered to the flow of current by the resistance and the what? Capacitance. And with a column, impedance. Impedance, Z. You see, if this circuit were to be a resistance circuit, a capacitance circuit, and inductance, that's three of them being there, it means we're going to consider the three elements opposing current there to determine the denominator as to Ohm's law, right? So in this case, the formula for calculating our current I is going to be V divided by Z. That's what we're going to use. Where V already we know that this voltage here in the AC circuit, which is 10 volts, but we don't know Z. We don't know Z. Let me indicate unknown. And so we have to find the value of Z. The impedance. Impedance is the opposition offered to the flow of current in an alternating circuit by the combined effect of resistance and inductance and or capacitance. Okay, so we're moving. We have that Z is equal to, for a circuit, AC circuit that contains resistance and capacitance, the formula for calculating impedance is simply the square of the resistance plus the square of the capacitive reactance. So our Z is not going to be square root of R is 500, I'm going to square it plus, then XC is 636.62, I'm going to square it. So this is going to give us that Z is equal to, let's find out, so I'm going to press square root or open brackets to enclose this, alright, in that square root sign. So 500 raised to the power of 2 plus 636.62 raised to the power of 2, close the bracket, equal to. So this gave me 809.5 approximately. 809.5. The unit again is ohms because it is an opposition to the flow of current. Implication: the current in this AC circuit will now be V over Z. We know V already to be 10 divided by Z, which is 809.5. And once we press that in the calculator, 10 divided by 809.5, from here it gave me 0.012 ampere. So this is the alternating current in that circuit. I'll be going for a short break. When I'm back from the break, we shall look at the third part of the question, where we are to determine the voltage across the capacitor. Of course, we'll be thinking of V sub C equal to IXC. So you're welcome from the short break. Before the break, we've solved the first and the second part of this question. We are now left with the third part of the question, where we are required to determine the voltage across the capacitor. That I'm going to use V subscript C. Friends, always remember all these are basis of Ohm's law formula. Is that okay? Now to calculate voltage, it's equal to current times the element opposing the current in that circuit. Now, the voltage we are required to calculate here is simply the voltage across the capacitor, not the voltage across the resistor, not the voltage in the circuit, just the voltage across this capacitor. It therefore means that I am going to use the opposition to the flow of current offered by this capacitor. to represent R if you're thinking about the Ohm's law concept. Is that okay? Which in that case, V equal to IR will now become V equal to IXC. Where XC now is representing the resistance, because we are dealing with the capacitor. That's what we asked to find the voltage across. So this is going to be I, current in the circuit, multiplied by the capacitive reactance. So having said this to be the formula, I'm going to use my blue marker to complete the solution. All we need to do is to substitute. V sub C will now be equal to the current. In the circuit, we obtained it to be 0.012 ampere. And in this current, sometimes, let's assume that one is taking an objective examination. You could see this to be 12. Are you following, right? 12 milliamps, milliampere. You can convert this to a milli value by multiplying it by 1000. If you multiply this by 1000, you get 12 milliamp. So take note of that. Now, coming back to the voltage across the capacitor, current in the circuit multiplied by the capacitive reactance, and the capacitive reactance, before now we obtained it to be 636.62. So if you multiply this out, the value this is going to give to us 0.012 multiplied by 636.62. Okay, so this is 7.64 volts. And this is the value of the voltage across the capacitor in this RC circuit. In this video, we want to determine certain parameter for an AC circuit that contains resistor and inductor. Alright, the question reads, in an RL circuit, the resistance and inductance are 500 ohms and 150 millihenry respectively. If the frequency is 50 Hz, find impedance of the circuit. That's A part. Then part B of the question, voltage across the inductor if the voltage in the circuit is 10 volts. Alright, so this AC circuit is a resistance-inductance circuit. Is that okay? So in the first part, we're asked to find the impedance. From the question, we know the resistance value. So let's bring out what we know. R is 500 ohms. And then we were given the value of the inductance, L. Alright, L is 150 millihenry, which is the same as 150 times 10 raised to the power minus 3 Henry. Remember, milli is the same as dividing that number by 1000 is the same as multiplying by 10 raised to the power minus 3. The frequency of the alternating current was given to us to be 50 Hz. In the first part of the question, we have to determine the impedance. So Z, we're using Z because this circuit is made up of two different elements that are opposing current, which is resistance and inductance. So when you have resistor and inductor in a circuit, to calculate the impedance, we recall the formula. Recall that Z is equal to R squared plus XL squared. XL squared. So this is the formula we're going to use where XL is inductive reactance. But how do we get inductive reactance? We need to calculate the inductive reactance is equal to omega L. Omega L, which is still the same as 2 pi FL. So we can substitute into this 2 pi times the frequency. The frequency is 50, which is going to be 50 times the inductance. From the question, the data given to us is 150 times 10 raised to the power minus 3. Look at that. So if we reach out for a calculator and press, this is going to give us 2 pi multiplied by 50 times 150 Then this times 10 raised to the power minus 3 is the same as divided by 1000. And this is giving me 15 pi, which eventually becomes 47.12 ohms. So this is the inductive reactance, the opposition to the flow of current offered by the inductor in this RL circuit. But for the A part of the question, we are asked to find the impedance. It's not only the inductor that is opposing current here, the resistance is also opposing what? Current in this AC circuit. So for us to proceed, we have to determine the value of Z. So it implies that Z is equal to square root. We have the formula down here already. So that's going to be 500 squared plus 47.12 squared. If you work in this, the impedance is going to give us Z equal to square root, open bracket, 500 squared plus 47.12 squared, close the bracket, and this gave me 502.22 ohms. So this is the impedance in this circuit. Now we're going to move on to the second part of the question, where it is required that we determine the voltage across the inductor. So it's going to be VL. In the previous question number 4, I've already explained this concept and what we need to know about voltage across any particular element. If you're calculating voltage across the resistor, it's going to be V sub R equal to IR. Alright, then we saw that of voltage across the capacitor in question number 4. This time around, voltage across the inductor is going to be IXL. That's going to be the formula. I would use blue marker to proceed in this solving of this part. So our VL now is equal to current in the circuit. We do not know that. So we have to determine the current in the circuit first. Is that okay? And to get the current in the circuit, it's going to be voltage in the circuit divided by the impedance in that circuit. So I'm going to write something here. This current is equal to voltage in the circuit divided by impedance. Alright, so I will close that in bracket and multiply it by XL. I hope it makes sense, right? This current is current in this circuit. In the question, the current was not given to us. So we can find the current by dividing the voltage in the circuit by the impedance. Good enough, we've calculated the impedance already. So this is going to be voltage in the circuit. We got it, okay? It was given to us from the question. Voltage in the circuit was given to us from the question. Let me indicate it, please. Voltage in the circuit is 10 volts. That is instantaneous voltage. Now, if I substitute for this voltage, it's going to be 10 divided by the impedance, which is 502.22. So I'm going to multiply this by XL. And XL is 47.12. So the voltage across the inductor is not going to be, reach out for the calculator and see what it gives to me. 10 divided by 502.22. So I'm going to multiply this. I'm going to multiply this by 47.12. Okay. So this gave me 0.94 volts approximately. So this is the voltage in the inductor, across the inductor rather, the voltage across the inductor for this RL AC circuit.